All right, we have started the blue sheets around. Given the number of people in the room, we just sent one set around. So please make sure that it crosses the aisle to the other side. Carlos, do we have the scribe yet?
No. So we need a couple of volunteers for the minutes and for the Jabber. So any volunteer for that?
We can't start till we have both roles filled. Come on, we need a note taker and a Jabber scribe.
Russ?
Hello, hello.
Okay.
Hi, it's Dorothy Stanley, HPE. Russ, I'll volunteer to be a note taker.
How long?
I can stay till 11.
Okay. Thank you, Dorothy.
Okay.
Come on, Jabber scribe's the easy one.
I'm new to it. So what is it about?
So Jabber scribe, you go into the Jabber room, which is IPWAVE@jabber.IETF.org. And if somebody has something that they are listening on the audio stream but wants to contribute, you go to the mic and say it for them.
I don't know.
You don't have a Jabber client?
I'm not sure.
Okay. No, we need somebody who has a Jabber client. All right.
But can you take some minutes, some notes?
Okay. Thank you.
Sorry?
I'll detail.
It's just about mainly the decisions is what is.
Yeah. And we'll merge them with other people's notes. All right. I will do the Jabber scribing then.
Sweet. I don't know the plan. I can take notes, but I don't know.
Okay.
Okay, so
All right. Thank you.
thank you.
You don't need me to take notes?
No, he said he can do it. Are you going to do it in the Etherpad? Or just mail it to us? Either way is fine.
I'll send it.
Okay.
Fine. I just want to know. All right, thank you.
So
You want to do the?
yeah.
Okay.
So here's the IPR note. So please be aware of it. Also the note well.
We should highlight that the note will change since the last meeting, and since we're the first session of the day or the week. Please take a look at it, and the last bullet on the slide is, for example, new. Thank you.
So well, we have already gone through this. So blue sheets are around. Well, actually, it's only one. So please, as Ras said, be sure that it circulates over the whole room. Note takers, thanks for the volunteers and the Jabber scribe. So this is the agenda for today. So, well, the first part of the meeting will be focused on the working group documents. So we have two at this moment, which are the only two charter items that we have. One on the IPv6 over A02.11 OCB that we hope that we will be able to close the main issues during the session today. That's the goal. Then we have another slot for the other document, the use cases survey and problem statement. And with this document, we'll also go through, that will serve as starting point for the last part of the meeting, which is about rechartering. So at this point, we are just exploring what topics could be in a potential recharter if the working group and the ADs believe that this is a good move to do. So there are different presentations by Sri on IPWave news extensions, by Jerome on access categories, by Paul and by Alex. And at the end of that batch of presentation, we'll have some time for discussing what the working group believes is the next step to do. So any comment on the agenda? Okay, so then a brief status on the working group. So as we mentioned, we have this couple of documents adopted by the working group. The first one, the transmission of IPv6 packet over OCP. We have a lot of discussion after the first working group last call, and there have been a lot of revisions since then and lively discussion on the mailing list, especially during the last few days. We also started a second working group last call recently before IETF, because we believe that the only main pending issue was on the QS data header thing that Alex will discuss later on. So the aim of that working group last call was just to check if people were happy with the rest of the document, knowing that this is an issue that needs to be resolved. And the goal is that we close that issue today. And if there is any other comment, big issue, we start the final process for the publication, meaning that we need to, as stated in our charter, we need to send the document to 6 months for review. And then after that, we can submit to the AEC. So that's the plan. Let's see if we close the issue during the meeting today. So that's on the first document. On the second document, this document requires quite a lot of discussion. We haven't seen almost any activity on the mailing list since or between meetings. So this is something that has to change if we want to really publish that document. Without any review activity, that will be not possible. So this is a clear message for the working group that if there is no activity on this document, we'll have to drop it, because, I mean, it doesn't make sense that we publish a document that nobody has reviewed or contributed. So please do look at the document, contribute, provide reviews. We will talk about that later when the document is presented. And it's also important, this document, because since it's about the problem statement, this should be the basis for potential recharting. If we really want to do this, those topics that we want to tackle should be reflected in the problem statement. It will not make sense to do recharting topics that are not documented as problems, that there are sys gaps on those. So this is also very important. This is just a summary of our charter milestones and where we are. We are late on both of them. I hope that we managed to close the main one on the IPv6 over OCP after this meeting, and the goal will be to be almost done with the other one by the next meeting. Otherwise, if there is no activity like in between the last two meetings, maybe the best decision will be to drop that document. Then we got a liaison statement on the mailing list, so maybe Raj, you can summarize on this one.
So we got this liaison statement that was posted maybe a month ago that says that there's work beginning in SAE on this topic, which is basically focused on using LTE and 5G for communication vehicle to vehicle. And the action was to tell them if we saw any overlap. And so we just remained silent because we're clearly working on OCB, not on LTE or 5G. And so they asked us explicitly, are you guys going to respond? And so we responded informally in email, as opposed to putting in yet another entry in the liaison stuff. That was copied to the list. And so you all should have seen that discussion. I think we're done with that because we're not taking on any work on LTE or 5G. If somebody thinks we should, that part of the discussion would belong in the last agenda item today. Any questions about any of that? Okay.
Okay, thanks. On the last kind of update is on the Ips Communication Standards. There was a meeting of that in March the 9th, so like 1 week ago, or a bit more. And we were invited to present on that meeting what we are doing at IETF in IPWAVE. So we remotely presented that. There were different presentations from different SDOs working on vehicular communications on that. Well, basically, you want to take a look at the agenda of what was presented there and what were the materials that were presented. You have the link there on at the end of the slide. And then just before going into the actual presentation, just a brief summary of next steps. So again, the main charter item of the group is on the IPv6 over OCV. So the goal is to clear pending issues by this meeting, and then of course get a confirmation by the mailing list. And after that, request the 6-month review of the document and proceed with the last steps of the publication. Then again, a call for action on the second document. We need activity on that. Otherwise, it's not possible to really move forward. And then we will have some rechartering discussion. And one message is that during the meeting, we will not take any decision, of course, on that. It's just about discussing and see what the working group wants to do on that topic. So if there is no comment, we can then go to the first presentation. Alex?
Please remember to stay in the pink box if you're presenting so that the remote participants can see you on the camera.
Thank you. Hello, my name is Alexandru Petrescu, and I will present the draft transmission of IPv6 packets over 8.11 networks operating in mode outside the context of a basic service set. My co-authors are Nabil Benamar, Jérôme Harry, Christian Huitema, John Hughley, Thierry Ernst, and Tony Lee. So next slide. I have a very small set of slides. Okay, it's just about 3 or 4 slides. First, I will overview the changes that happened in the draft since the last meeting. And second, I will illustrate the proposed changes that happened after the deadline of draft submission. Because we can have many versions of the draft, but at some point there is a deadline, and the deadline was on March 5th, and that's where we stopped with. Since then, some changes were proposed that I will list here. So, what happened since Singapore? The most important thing is that we tried to orient the text more in a normative manner. That means to use the normative keywords: must, should, recommend, where appropriate. Instead of having a description, like an observation of what happens in the implementations, we now have decided which are our normative phrases. For example, must use an Ethernet adaptation layer. The MTU value must be 1500. It is recommended to use the stable interface identifier, and must use the multicast and unicast address mapping that is described by RFC 2464, also called IPv6 over Ethernet. So since Singapore, we added these keywords in the appropriate places. Some cosmetic changes with respect to definitions. We have improved the definitions of 802.11 OCB, of IP RSU, IP OBU, and this it offers clarification with respect to the existing terms RSU and OBU that have been moved in an appendix. We have further removed more text. The fragmentation behavior has been removed. Mentioning of WSMP geonetworking was removed. The explanation of the binary representation of the ether type was removed. Reference to a TSV working group document about QoS and Wi-Fi was removed. And we removed also the paragraph about addressing model subnet structure and the easiness of using link local addresses. And right before the submission deadline, because we had no agreement or there was no concordance between the opinions expressed on the email list, we wrote 802.11 header instead of 802.11 QoS data headers or 802.11 data headers. That's what the draft has in it today, just 802.11 headers, in order to be a little bit resilient to what may happen after. That means in the last week or two. So in the last week or two, we agreed that we will propose that we will introduce this change in the draft. And this is the text that we will add when the submission opens again. The text is this, I am reading it, start at the beginning. The IPv6 packet transmitted on 802.11 OCB must be immediately preceded by a LLC header and an 802.11 header. In the LLC header, and in accordance with the EPD, Ether Type Protocol Discrimination, the value of the type field must be set to 86DD, hexadecimal. In the 802.11 header, the value of the subtype subfield in the frame control field must be set to 8. That means QoS data. The value of the traffic identifier subfield of the QoS control field in the 802.11 header must be set to binary 001. That means user priority background and QoS access category AC_BK. In the Ethernet 2 header, the value of the type field must be set to 86DD, means IPv6. And remove this text down here, which means the other alternative use of layering the EPD. Other alternative use of layering are EPD, described in Appendix E, and SNAP. Okay, so basically because EPD is not an alternative view, it is the view. And SNAP is because we do not use SNAP. So these are the last proposed changes. And well, I think there is some agreement. Many people agree to it, and I also agree with it. And this is what we will introduce in the version in the next version of the protocol. And yeah.
So if anyone has an opinion about this text, we'd certainly like to today settle this issue about data or QoS data. Please come to the mic if you have any concerns with the resolution Alex has just proposed.
Hello, this is Paul from SKKU in Korea. So actually I didn't follow the mailing disk in detail, but I have some concern about a class of QoS, control field. Actually, background and best effort IP has minimum window slot and maximum slot is the same, which means in terms of quality of service, both classes are equal. My concern is IP wave traffic may be important, such as deliver some collision avoidance or adaptive cruise control message. That message should be delivered quicker than other background traffic. So if we stick to background, my concern is that kind of application use cases doesn't work. So I need to get some feedback. Why you decide background priority? Could you describe the previous email discussion? Why did you decide the user priority background?
Yes. So, to be short, this use of background is to compare with other traffic in the network that is not IP traffic and that exists today in some places and that may want to be more priority than the IP traffic. But at the same time, I also agree with you that in some circumstances like cooperative adaptive cruise control or platooning, IP may be used, and some of the IP messages for these platooning scenarios must have a better priority than just background. But I do not worry very much about this. I do not see it as a problem because I think it is possible to have background value for IP today in general, and later have maybe another document that has some special IP over other priority like maybe a priority that is not even yet defined, right? Because right now only 4 priority are defined, but they don't have names that are appropriate for vehicle network. So I agree with you that the worry is valid, but I think it could be solved later. And today in deployments, just let's try to distinguish IP from the other traffic that exists, that is non-IP.
I think the IEEE as you know, Wave protocol stack has 2 network layers. One is for the IP, version 6, and the TCP, UDP application layer. The other one is 1609.3 network layer case. They specify some other Wave sort message or basic safety message, something like that. They think that is good enough for some applications such as adaptive control or the pro-tuning, something like that. But I believe IP-based some adaptive cruise control and pro-tuning also will be popular because many the programmer in internet, they are familiar with the IP. So perhaps in the near future, we discuss this issue with the IEEE. Do we need some another category? Probably we can ask them. Okay, that is my suggestion. Thank you.
Yeah, probably, yeah.
Okay, thanks. So then we consider this as an agreement. We will then proceed with sending the document to the 6-month review. And I guess Suresh, you will do that, right?
So yeah, whenever you're done ready, like I can send it off. Like probably start off after the meeting. Because like this week, nothing is gonna get done. I send it over. So probably like Monday, I can send it off to 6-man. Probably wait for 2 weeks and then like do the regular processing. So I'll do the AD eval, the inter, and then
Okay, perfect. Thank you. So then, thank you, Alex. Paul?
Okay, let me start. Okay.
Maybe. No, not. 1 second.
Okay.
I don't know why this is being shown there. 1 second, let me try to. Okay.
Hello, everyone. This is Paul from SKKU. Frankly speaking, internally, there is a lot of some suggestion from especially Charlie Perkins. He gave a lot of comments. Parts of his comment we reflected. So still we working on it. And then this version, we try to address Charlie's other comments. And then after our meeting or during meeting, you suggest the comment. This document is very important. We made a lot of effort to make a survey and problem statement use cases for the basis for our next steps. So please read this document and give us comment. So those are the authors. Next slide. So the updates from the previous version. So this is the major changes. The first one is a reference of DSRC is added. The second one is the definition of RSU is updated. So RSU can be connected to internet or not. So, and also the definition of DMM is used for the problem statement and the survey. And the first one is the communication of radio access network for emergency network with 4G LTE for I2V, V2I, vehicle to infrastructure. Currently, the radio access network for emergency network is implemented by the 4G LTE, but I believe the Delta 11, the OCB also can be used. And the last one is the network layer of a wave is classified for IP networking. So the 1609.3 describes the network layer of a wave. So they have their own IP configuration mechanism to reduce the delay caused by neighbor discovery of original IP version 6 stack. So the previously I mentioned the stairless address auto configuration, I change wave address auto configuration, something like that. So the first, okay, let me show you the major updates one by one. The first one is we added the DSRC reference for FCC channel assignment for wave DSRC. The second one is RSU definition. So RSU may have multiple physical communication devices, so not only DSRC, but also visible light communication or other Bluetooth, other communications. But I believe the IP wave, our working group is focused on Delta 11, the OCB mode. The third one is we added DMMN acronym, so distributed mobility management in terminology section. And first one is, I mentioned the radio access network, RLAN, is mainly constructed by the 4G LTE. But I mentioned in near future, DSLC, especially L2.11 OCB will be used. So lastly, so I clarified the configuration of IP. So you can see right-hand side, 16093 describes the network layer in Wave protocol stack. So they providing their own mechanism based on Wave service advertisement management frame containing a gateway address, IP address, DNS server address, subnet prefix, something like that. But this one doesn't use original IP version 6 neighbor discovery. So we needed to name another name, such as a Wave address auto configuration, something like that, instead of a Slack. So next step is synchronize with our OCB document. So we improve the get analysis and the problem statement with our OCB document. And also, we also will enhance the use cases section, including more industry activities. And also, according to our milestone, we try to finish this document, and then I will request the working group rest call after reflecting your comment this meeting and after meeting mailing list. Thank you. Yeah. Any questions or comments? So maybe I think some experts such as Tri or the Alex or the Jeremy, other people can read this document in depth, and then please, give me the comment. Okay.
Yes, hello, this is Alex Petrescu. I will read the document, give more comments. I have sent in private some emails last days. I'm not sure whether they may...
Reference, right?
Sorry?
You send some good reference,
yeah,
right?
Yeah, some, because during the discussion on the working group list, one or two people made mention about deployments where IP is used on 802.11 OCB. Okay? And I think it's good to refer to these trials. Yeah. Like there is a trial in with a police department in New York City. And then there is some other trial with some other company somewhere in America. I forgot the name. So these two things, and they said they use or strongly consider the use of IP to connect to SCMS or to connect to some certificate or to some back on OCB link. Okay, that's very important to mention.
Okay, so I will add the Alex, you provided the for use cases, right?
References.
Okay, or references. Okay, okay. Appreciate your contribute. Okay, go ahead.
I'm Justin Dean from the chair of the Man-A working group. I've looked over the draft, and my comment is more that it reads more like a collection of solutions and less like a problem statement. I had a hard time figuring out what the problem was, and that was what I thought the document was going to be expressing, but it wasn't. It was giving solutions and options to solve different problems, but it didn't, to me anyway, clearly state what the problems were to solve. So my input would be to clean it up in terms of what you're trying to convey, and then work on selecting solutions. I know I've seen many working groups come and go that have tried to solve everything. And I think if you nail down the specific pieces you're trying to solve and just go with something or give options, you might get too deep into trying to solve everything. So I think having a very concise problem statement document would be good for the working group going forward, but I don't think it currently is that.
So let me clarify your question and comment. So originally, this document is designed for survey to survey IP-based virtual networking. So that's why we have a lot of some domains, including many stops, and then we try to analyze the problem. But I think your comment is correct. We need to focus something, right? So we try to address what kind of problem we have to solve in our working group. So definitely we do. Okay.
So again, I think you said it yourself. It read more like a survey of different solutions rather than the problems, the specific problems you're trying to solve.
Okay, sure.
I agree with you.
Okay. Appreciate your comments. Yeah.
Suresh Krishnan, so like, are you willing to help, like, fix this, or do you have like specific actions they can take? Because like one of the things that we are trying to do in the IETF here is not to sequence the problem statement and the solution. Okay, so that's why like we have this like grab bag of things of like all the support documents together. Okay, so if we think like a focused problem statement is useful, like give that feedback, and we can certainly like accommodate that. But it requires like people to comment, and because this document has not seen much activity.
Right, and I coming from just the experience of working groups, I think that has to be driven by what people want to fix. I mean, what are you trying to do? And the problem statement should be driven by what you're trying to do. Are you trying to do you need multicast? Do you need fast switching to get to the internet? Are you trying to do vehicle to vehicle? Are you trying to do DAD? Are you trying to do mobile IP? Are you trying to do NEMO kind of stuff? I mean, they're all different problems.
But that's solutions based, right? Like, you know.
But they're kind of mixed up together, but there are different ways of solving those problems. But any one of them individually are problems, and you can have a suite of problems that is what a VAN A would look like, or what a vehicle network would look like, and what the problems are in that space. And then there are multiple different solutions. And I think going into the solutions in this document gets a little bit too muddled in terms of what you're trying to convey with it.
Right. My question is, are you willing to like write it up and work on it like in a given reasonable time frame? Let's say
me personally,
I'm like, can they note it down?
Me personally, I'm not. I'm willing to look at it, but I think that has to be driven by the solutions that people want to solve in this working group. That would be my comment to you. What are people trying to solve in this working group, and what is that problem? It's got to be driven by that.
Okay,
in my
so
opinion.
If I understand you correctly, your comment is like there's too many things in there, like, you know, make it down to something smaller. Would that be like fair summary?
If you're going to go with the document name of these are the problems we're trying to solve, I think it has too much in terms of possible solutions and a survey of solutions in that document, and breaking that out into solutions of, you know, problem section 4.2, and you could have a different document that's, hey, this document is, these are a survey of what we're trying to solve in the problem statement document. But right now they're kind of merged together.
Right, and so that's kind of like, I would say, that got driven by me, right? Because like one of the things we are trying to do in the IETF as a whole, so this is not related to this working group, is to minimize the number of support documents, like, you know, the use case documents and everything. So like, so not to focus the working groups on that. Okay, so that's why these two documents got combined. They were like separate documents at some point. Okay, so like we got like, you know, feedback from the IESG that like, you know, we need to reduce the number of support documents. Okay, so when I originally charted this, we had like 3 documents like in there. So if you can throw up that slide, Carlos, right? There were like separate things in there. So if the working group wants to go that way, like I'm okay with that. Okay, so I just want to see more support in the working group too, because there's like quite a bit of effort invested in putting these documents together. Okay, like I think like Charlie did like work with you on that, merge these, and if that's the right answer, that's okay, right? But I haven't seen like the same comment that you made from other people. So if that's what the working group wants to do, that's okay with me.
I'm thinking out loud here. Another way you could go is have problem statement, either 1 or 2 surveyed solutions for that problem statement, and then you go to the next one. And then if that would be a different kind of document that these are the problems we're trying to solve, and this is a proposal of how we're going to do them using other known technologies, and this is kind of the suite of what a VAN-A would look like. And I think there's value in that, so that, you know, one person that deploys it one way and another deploys it the other way and the protocols aren't the same, is not going to work together. So I think having a document that is explicit in saying, you know, these are the problems and these are our solutions, and this is kind of the suite of protocols that you're going to run to solve it, that's a different document, but I think that's also valuable. And this was closer to that than it was a problem statement.
Okay, thank you.
So, sorry, one question just to clarify. So if I understood you properly, what you are suggesting is that that document first kind of analyze or describe a set of problems, then goes into describing a set of solutions that could be applied to those problems, but specifically to those problems, not like a general survey of anything. And then probably guess that the missing part will be if there is any gap that has not been solved by those solutions, to highlight that, right? So it's problems, solutions that are already there that can be used, and if there is something that is not completely fixed or solved, highlight those gaps, right?
Yeah, that seems reasonable. Two points to that. My main hang-up was the document name didn't seem to follow what the document was doing. And the second one was, if you're going to do that, as chairs, I would be weary of trying to do everything. So don't get bogged down in trying to solve everything and getting it perfect and getting it right. I mean, if you're trying to get something that's a solution, and there are solutions out there, there's value in just putting what you know down.
Okay, agree. So then I think it would be good if we try to get some volunteers in the room that commit to provide to make a review and try to provide suggestions to go into this line, because otherwise I'm afraid that we may end up with the same situation in the next IETF. So I don't know if, is there any volunteer in the room that commits to take the document and in like 2-3 weeks time frame provide a good review to the main list? Okay, thank you. Justin.
Thank you. Yeah.
Okay, thank you very much.
Okay, thank you very much. Okay, let us make progress. Thank you.
Okay, thank you. So now we then go into the kind of rechartering base or related discussion. So I guess that maybe Suresh can, before we go into the presentations, Suresh, maybe you can, before we go into this rechartering potential discussion, maybe you can just provide some guidance on how to do that.
So yeah, Suresh Krishnan. So we had like a larger charter like for this working group than was approved. Okay, so we put together something, and there's like quite a bit of discussion on the IESG, and like we kind of narrowed it down to like these items. Okay, so that was like kind of related to how much would fit in the interior. So like one of the things that was like in there was like multi-hop. So like, you know, Alvaro and I discussed it and realized like we don't want to reinvent routing protocols here. Okay, so that's kind of something that got thrown out like of the original charter we put up to the IESG. Okay, and so think of that as kind of like a bound that we don't want to do routing protocols here. Okay, that's really a limitation. And the second thing is, I really want to see progress on the problem statement before we recharter, because if you don't have a common agreement in the working group on the set of problems to solve, I don't want to recharter. And that's like something that's concerning to me and to the chairs as well, that this document has not seen that much activity as the OCB document, P6 document. And I would kind of put it as a precondition for a recharter to have like a good discussion of the problem and agreement on the problem. Okay, and like, so today's session is like, you know, people presenting things to do, but I want to see some kind of working group backing to solve these problems, okay, before I put up a charter to the IESG.
Sri Gundavelli. Suresh, from my point of view, at least from my experience, I've never seen a tight correlation between the problem statement and the work that followed so far. I'm not saying this document should not be done, right? But just saying that everything whatever we do has to be on the basis of this document is probably, I don't know. Yeah.
So personally, right, like if the problem statement doesn't exist, that doesn't bother me. Okay, so this is like what I've been saying from the beginning. The problem statement is like something for the it's a working group document for the working group, really, right? Like whether or not it's published as an RFC is like a completely different story. But the thing is, like, people have not discussed the problems that need to be solved. Okay, your presentation is like the first time, like you're talking about this. Okay, so I want the working group to agree on the set of problems. Okay, like it doesn't matter to me if it gets published as an RFC or not. There's like a lot of problem statements we've thrown away. Like like Alvaro and I have abstained on a lot of documents. Like for example, right, because that's not the important thing. The important thing is the working group agrees on a set of problems to solve. And I haven't seen that discussion, okay? Maybe like, today's presentations, like, ignite that discussion. Maybe the LS, like, Jerome was like talking about like, doing this cellular thing. We don't know, right? But that needs to happen in the working group. I haven't seen that happen in the working group. Like the main discussion has been about IPv6 over OCB. Like that's the right thing to do because that's like the solution document that needs to go out first. But I want to see the discussion in the working group before we reach out. Because it doesn't matter if like two people want to solve a problem, right? Like that doesn't make a working group. So we need to make sure that there's support in the working group to solve something, okay? And I want that reflected in the problem statement at some point because like otherwise there's no value in publishing the document. The reason like, there's pushback is because the problem statement and the solutions don't match, like you said, right? And that's why it does not make sense. And most of the time, the problem statement is outdated by the time the solution is done. And we've seen cases where the problem statement comes like 2 years after the solution statement into the IESG, okay, or use case documents. So at that point, they lost their value. Okay, so that's really the background for all this stuff, right? My concern is not that the problem statement doesn't have reviews. My concern is like nobody has discussed the problems that need to get solved in the next phase of this thing. Okay, so that's really the background.
Whoever has the blue sheets, could you hold them up?
Okay, so then 3. Here you can.
So a quick update on the potential work items that this working group can take up. So if you look at, let's look at the context, right? Right now, why connected vehicle and this vehicular networks is an important topic. If you look at it from the DSRC point of view, all the regulatory clearances are out there, essentially the 5.9 gig and essentially the allocations and all of that is in place, right? And IEEE has already made progress with respect to 629 standardization and the wave standards are out there, right? And at least the MAC layer and other stuff, right? 3GPP has a study item on the cellular V2X and they've explored various use cases and some work has already happened there, right? Now with respect to safety messaging, SAE has specified the safety message set, right? There are 2 documents. One is on the J2735 on the vehicular safety. All the messaging elements are there. That extensive amount of work went in there as well, right? And also the onboard unit requirements. Now, with us coming back to IETF, this working group, the initial focus was on specifying IPv6 support on the 802.11 OCB media. But if you look at that work, fundamentally all it said was how to transmit a packet on the medium, right? That's about it, right? There's absolutely no discussion on how neighbor discovery works or any of the other things. No discussion on the link model. All, I think it's perfectly fine. It's just about mapping. There's an IPv6 packet. Now, how do I transmit on a particular layer to media? To that extent, I think that document did a great work and it provided the background. It's all, fine in a lab environment. If you put 2 RS units and a OB unit, sure, IPv6 will work. But in reality, if I put, the OBU in a vehicle and if I'm driving at 60 miles per hour, will I be able to have essentially, access some cloud application or not? That part is not clear, right? Essentially, nobody has, Tony, yeah, go ahead.
Tony Lee, it works just fine. There's no changes necessary.
So just to say if I got it right, so you said that everything works, that nothing is required to be done, right? This is your comment.
Once you have IP working on top of OCB, it just works. It's happy. You don't need a special version of ND. You don't need a special version of anything. As far as IP is concerned, it works just like an Ethernet. Up until the point where the radios disconnect, it's happy.
No, I understand. IP works, right, essentially, but is it in a form, will I be able to make, keep my, will I be able to use it in a reasonable fashion, right? I establish a session, right, to some application. What will happen? Will I keep, how does the system work from end-to-end point of view, right? How does neighbor discovery work? How do I identify other nodes? How do I there's no discussion on who holds the prefix.
Just like an Ethernet. Everything just works until the radios disconnect.
I think, Alex, go ahead.
So yes, there is this, I agree with Tony, there is some magic, okay, just works.
Sure.
But you also said in a lab environment versus on the road. Also in the road just works, but there may be some issues with this handover. Okay, I will ask Tony in private how is his handover doing, and this handover means some neighbor discovery, maybe. This is what I think may be somewhere.
So every 1,000 meters, if there's a RSU unit, our argument is that the vehicle is moving at 60 miles per hour, and we'll have, no issue to the communication. Everything will work great. There's some magic. I don't understand, but I leave it at that. I think, that's what, yeah.
So
we can discuss.
Yeah.
So yes, I think we need some discussion yet. I mean, I'm not saying arguing against or in any of the two positions, let's say, but I guess that your point is that the IP over OCB works, but there are some things that could be optimized. Like, I mean, based on mobility, I guess the privacy thing is also something that may need some additional work. I'm just saying, putting things on the table, and I guess that the discussion on whether this is a need or not is what we need to have in the working group before taking any decision. So it seems that there are two positions here. So we need to have like this discussion to really understand whether IP over OCB just works and nothing needs to be done, or there are things that could be optimized in a real environment operation.
Right. I think the question is when we say that it works, right? What does that mean? That works, right? Essentially, that's the point. We need to clarify. I think, yeah, exactly. The point is, some optimizations are needed. What are those optimizations? I do not know, but I'm reasonably sure that some optimizations are needed.
Yeah, this is Jerome Harry speaking. I think it's really about semantics. Working, fine, it works, sure. Does it work efficiently is another issue.
Right.
We have a high mobility, and that's something we have to configure quickly, and then we have to maximize the communication during the connection time.
Right.
These are things that even the neighbors around one vehicle, an IPv6 neighbor list or neighbor table might change very rapidly. We have to adapt. We have to check, first of all, and second, adapt to this kind of environment. So working, sure. Working efficiently, this is something we have to discuss.
Right.
And even though that we spent a lot of time on the first document, the IP over OCB, from my perspective, this was just kind of the opening the door, and then we have to do the real job, which is improving the efficiency on IPv6 over a highly dynamic and mobile environment, which maybe not specifically linked to OCB anymore, but I just stop here.
No, absolutely. I think there's fair points here. Eric.
Eric Nordmark. So trying to understand what the network provides and what it doesn't. So clearly, I agree with Tony in that, yeah, if you're talking to one roadside unit, you're getting an IP address allocated as part of that. It just works, right? When you move to another roadside unit, is the network providing the ability for you to keep your same IP address or not, right? People could deploy these networks in different ways where they do some form of mobility handling on the networking side,
similar to what you do in cellular networks. You don't actually see that when you're moving, when you're doing handoff, right? And I have no idea what they're planning on doing.
Right.
So that might be a question. I don't know if anybody in the room knows the answer to that question, or whether this is still open from the other SDOs doing work in this space, or whether it's up to deployment. But that seems like a fairly basic question we need to know the answer to.
Right. Yeah, that's a key point, Eric. I think, what you said, in cellular mobility, it works because there's MME, there's a huge infrastructure out there which can do with L2 mobility. Here, we didn't talk about that. I don't see a single spec which talks about how the RSU is connected to the backhaul network. There's no definition there. There's no definition on the link model. There's no statement on, who is hosting the prefix. In the absence of that, I cannot agree that this spec works, this approach works.
Well, it works while you connect it to that one RSU, right? So you can send a UDP packet and get a response back. Right?
Exactly. It's in like lab
you can't
environment.
have your SSH session open for a day because it's going to break, right? But
Yep,
nobody
absolutely.
does that.
Yeah.
So Krishnan, so just responding to one thing, Sri, right? Like you said, it doesn't work, right? But one of the things, so this is like kind of like a thing that IETF says, like we don't do architectures, we do protocols, right? So that's, if you look at it from that point of view, the question is like, it's not that like whether it works or not, the question is whether we need to do it here, right? Because like the other SDOs, if they're working on an architecture, we don't want to do it, like redo the work here, okay? So if your claim is nobody is doing it, then we can think about it, but I'm reasonably sure that other people are thinking about this. Like I'm sure like, Jody is going to walk up in a minute and say like IEEE is doing something, or, like somebody from 3GPP, like Jerome might come and say like, they're doing something. So we don't want to duplicate work here, okay?
Sure.
So if like you say that 3GPP works because like, this, like there's an X2 interface and everything, all those things are done by 3GPP, not by us, okay? So our link model is like, there's a PDN gateway that's sitting as a router, and only if you leave that thing, you're going to get a new IP address. So that's another way of solving it. So the truth is somewhere between what Tony's saying and what you're saying, okay? But I'm closer to Tony on this than you, that things don't work, right? But if you have some kind of measurements, like, if you have like specific pain points we need to fix, because if something is broken on the IP side, we need to fix it, okay? So I remember like, we worked together on LTE for the, the ND spec, like on doing the fixes. But if there's like specific things that need to get fixed, we can fix it. But saying like we need to do the whole thing, it's not going to work. So like if you have say like, okay, maybe my neighbor cache entry, like, it times out even before, like, I can establish the next link, then we have an issue. Okay. So, but those are the kind of things we can look at here.
Right. Absolutely. At the end of the day, some optimizations for this. See, I think we do focus on protocols, but we define protocols for operating environments, right? I think, we cannot lose track of that, right? So, yeah, with that, I think, yeah, we all agree that, the optimizations needed. Yeah, let's go with that. And moving on, I think, just, nothing new here fundamentally, from SDO's point of view, I think, so far the focus has been on the air interface, right? I think now, we are going on the track that, essentially, we want IPv6 to work. That means that, from the use cases point of view, there's an application in the vehicle which wants to access some other, application in the cloud, right? Essentially, or, safety messages going from the RSU unit to the car, or, vehicle to vehicle, right? That is one hop communication, or to the cloud, right? In all of these cases, I think it's in our interest that, we make, IPv6 work completely, but, in an optimized manner where we can truly, in a reasonably, useful manner. Now, I think going back, I think the question is, let's zoom into some of the ND questions, right? I think, maybe, this straightforward, I think Suresh, you said that maybe some SDO is already thinking about it. I think from my point of view, IEEE's focus of IEEE is not the system architecture. They are mostly on the air interface, on the MAC layer standardization, right? And they say they're looking at more at the messaging set, right? So nobody is looking from a system point of view, like, how does, one city or, entity, deploy these RS units, right? What kind of infrastructure they need, right? And what kind of, how can we make ND work in all of this? I think, some of the discussion points. The question is, from the link, at least minimally, we should have a link model definition, right? What exactly defines a link in this operating environment, right? In classic sense, like, or in, a bunch of nodes, attached to an access point, there, you see a VLAN or layer 2 link, right? Now, in a vehicular environment, zigzag vehicles are moving at 60 miles per hour, and for a short period of time you'll see like few set of few vehicles in path, and they may be in proximity for one of the RSU. those three, if you look at here in this slide, right, these three nodes for a time t equal to 1 are form a potentially one link because they're in a range where they can communicate, right? Now the question is, what is the prefix that is being hosted, right? And how do these vehicles communicate? How do the vehicles discover each other? How do ND works? Now, when t equal to 1 to t equal to 2, suddenly the scenario completely changed. You're at a different RSU unit. Now there are a different set of neighbors, right? Now, what happened? If you initiated ND here, and suddenly you're completely, your entire set of vehicles or your nodes have completely changed, how does this work, right? I think some explanation or some text is what we are looking for, right? Now, going back to, I think the question is, from system point of view, you should specify like the link model and how the prefix are hosted, what kind of we should explore if there's some optimizations needed with respect to DAD or with respect to general ND or other things, and also some discussion on the prefixes that are hosted in the vehicle. What is the topological relation to the RSU's prefix? Is it is it an overlay? Do we assume that a mobile IP kind of model where there's an anchor and the prefixes that are hosted inside the vehicle are coming from the overlay anchor, or are they delegated prefixes from the RSU? I think these discussions have to happen. I think some explanation is needed. From my understanding of the current IETF work, what we have done over the years, I do not know how to make use of that. Maybe you guys have an answer, you thought about it, but I do not know.
Yeah, this is really straightforward. I don't understand the issue here. Any prefixes hosted inside the vehicle should be natted. Okay? Yeah, nat. Well, I'm sorry you feel that way, but that's what's going to happen.
That's one possible answer.
You're not going to have everything inside the vehicle changing address every time you rehome to an RSU. It's just not going to happen. Okay? As to what's hosting the prefix, the router and whether that's co-located with the RSU or not is sort of irrelevant, but the router is the one going to be advertising with RAs. This hasn't changed. It's IPv6. No different. It just works.
Excuse me, I don't know whether that was some kind of provocation or something, but no, it's not going to be NAT in the car, okay? At least not for IPv6. And there are no IPv6 NAT in the car, yeah, that's for sure. And there are several ways to achieve it, and they could be discussed, and I think the question is valid. What is the question that you made, the relationship of the prefixes, the prefix in the car and the prefix on the roadside unit, are they somehow overlaid, or are they routed together, or is mobile IP or proxy mobile IP, or is it, and these are things that should be discussed and clarified, but certainly not today, not IPv6.
Okay.
Since Shri is up here, I'm going to take on the role of delivering a JabberScribe. In the Jabber room, the comment was on the previous slide. RSUs are not required for communication to happen.
RSUs are not required for, sorry? Yeah.
For communication.
Right.
Suresh Krishnan. So I don't think we need to solve that problem here. So that's a deployment question, and like remains to be seen if this is the place to do it. Okay. So you can go to DMM, right, and write like how to run TMF-v6 on top of it. We are talking seriously, Sri, right? Because like we are making IP run. So it's same way like we didn't say like how to do mobility on wireless LAN. Okay, we don't need to do it here. Okay, basic thinking, right? I could take out my phone with wireless LAN and walk like really fast to another access point. Okay, and we can make things work, right? Somehow. So either like by sharing the same IP prefix over multiple access points or not. So that's a different question. I'm not saying these questions are not valid. I'm saying like they don't have to be done here, right? Because at some point, this is like how some people deploy things, and maybe V6 Ops could be a place for doing it. Like maybe like DMM could be like a place for doing it. I'm not saying it shouldn't be done here. I'm saying like this is not the only place to do it, because like like this is like one layer on top of like, what we're trying to do here. We are trying to do IPv6 over FOO. Okay, so if you go to like Bluetooth mesh, like people are not like, if you go to 6LoW, people are not saying how to do mobility over this. Okay, like people in MANE are doing stuff. Okay, like for doing this, but like, so we have like a separation of responsibilities here. Okay, and this is really, I don't see that as necessarily being done here, because things work when like, so what you're talking about is like a mobility problem. Okay, so not a problem with like running IPv6 over OCB, to be very, very frank. Okay, so we can have the discussion, but I'm not sure like where to do that work.
Two points. Right?
Sorry. One question, just for clarification on my understanding. For example, if we find out that there is a problem of operating multicast, neighbor discovery, I mean, ARS things in this particular environment, that will belong here. Just for, so that's something that
right. Like so what I'm saying is like, don't presuppose a link model, because you have a link model that you already presuppose, saying like all these things need to be in the same prefix. Like what if there's like a link model which says like, okay, everything is point to point. We just don't know. Like, don't presuppose anything. As long as you keep it like generic and talk about what you're trying to solve, it's okay, right? But don't presuppose a link model and try to come up with a solution, because I'm sure people are doing different deployments in different places.
2 points, right, Suresh? I'm not arguing that the work should be done here. That's a problem statement. I'm saying, somewhere we need to do that. I think that's all I'm right. I think the second point is, we need to understand that, realize that 822 and OCV is for a specific operating environment. I think when we say IPv6 works, we should reasonably make sure that it works in that environment. I think that is the thing. Now, we can say that, Wi-Fi also, you can, say that, it's a very similar problem exists. We just defined IPv6, somebody else solved the mobility problem, but that was in CapApp. CapApp defined the mobility problem, right? Solved the mobility problems to some extent, right? So somewhere in IETF, we need to do that. That's all my point.
But CapApp solved it for like a specific case, right? Again, like they specified, okay, like the lightweight access points to solve this thing, right? So as long as like it's clear what we're solving, it's okay. But like you had like already 4 different use cases in there, because like the vehicle to vehicle, I think it's like a MANE problem, for example. Okay, so I don't want to like do anything here.
This is just a communication models,
Saying
yeah,
that, like, the slide was there, so I had to explain that, like, that's something we don't want to solve here.
Sure.
So like, as long as you clarify like what exactly you want to look at, I think we can look at it, but I think we need to be very specific.
Yeah, okay. Eric.
Eric Nordmark. So on the link model side of things, right, I think that we did discuss this a lot back when we started, or as we progressed with the 6LoW plan working group. So I think, I don't know how clear and concise that description is, but the notion that if something might have been a neighbor a millisecond ago, it doesn't mean that it's a neighbor now, right? The neighbors are the ones that you can hear or can hear you at any given instant in time over one radio hop. And that is a very dynamic environment, and it means that if you're going to talk vehicle to vehicle, it's the same thing as trying to set up, point-to-point connectivity with radio in general. It's basically just a reflection about what the radio reality is out there with hidden terminals, etc. And that one makes the system simpler to think about. There's not something that tries to hide this from you. If you don't want to talk directly, you can just say, okay, I'm going to send the stuff to my default router, the RSU in this case. And if the RSU has connectivity, okay, we'll actually get there. Otherwise, it won't, right? And that way you can start building things up. If, as part of the problem, and here's where sort of splitting the stuff apart and talking about different things, not in the same sentence, thinking about, okay, direct vehicle-to-vehicle communication. What does that mean? There's no RSU, right?
Right.
But I would not start that conversation bottoms up. I would not start thinking about IP. I would start at security. What does it mean for those guys to communicate securely? Right. And once you figure that out, you can figure out what identities do they have, and how do those things map to identities at layer 3, layer 2, etc. Right?
Right.
And that might very well end up being link locals might be fine for doing that stuff, and you have no acquisition delay in terms of acquiring them. You need to make sure you can actually talk, but that might go away any millisecond, which might be fine, right? But that's a very different thing, saying, I want my SSH session back to my server to stay alive as I'm driving around at 60 miles an hour. Like, well, maybe that's not an important problem, right? I want to be able to talk to an RSU. I want to be able to get services from RSUs as I'm driving around, and it's a local service that's one hop away all the time, right? That's a third type of problem. And,
Right.
and if you try to talk about all of these things in the same sentence, things get very confusing. Because it's not clear to me that from a security perspective, things are actually the same. Right?
Right.
If you want to say, I want to keep long-lived sessions to some far-away place or more than 2 hop place away, okay, you're going to end up with some overlay/mobility solution no matter what. And it's a question about, okay, we have about a dozen overlay solutions lying around in the IETF, and we have half a dozen mobility solutions. So there's plenty of things to choose from. We don't need to do that choice in this working group. We can just point out that, okay, for this to work, you have to have something that keeps stable addresses for this conversation, right?
Right. Yeah, maybe that, right, Eric? Yeah,
Yeah, it could be well, it could
Right,
be multi-path
right.
TCP or something, right? It could be
So-
something that can deal
absolutely,
with session continuity, right? So,
Yeah, definitely. I think at least if you can point to, this is the problem, or if you want to truly, make this session, continuity or whatever, right? These are the list of solutions. At least that documentation might be useful. I think at least minimally. I'm not saying we should go define a new protocol or something. It's not that, right? At least there are solutions A, B, C, and D, which IETF already has specified, which may be useful for this operating environment.
but yeah,
At least that discussion is sufficient. Yeah.
Yeah, but you need to start with what communication pattern are we talking about here?
Right,
Because
right.
the use cases, I think, are very different, and the security implications are very different.
True. Okay. Dorothy. Yeah.
So can you go back to the context slide? I think it's just a couple back.
Which one? This one?
Context?
Yeah.
Yes. Okay. I want to use this slide as a segue to share some information. The bullet on IEEE protocols and the .11 over OCB work. So the work to date has been based on 802.11p, and that is the product and the standard that's out there today. At the IEEE 802.11 meeting in March, so 2 weeks ago, in .11 we approved formation of a study group to look at, that study group is titled Next Generation V2X, so NGV. It's a new study group in .11 forming to look at extensions to the PHY primarily for enhanced range and better performance that would be completely and totally backwards compatible to the existing 11p PHY. This is very doable based on 11AC technology in the 5 gig band that just would use existing technologies in AC, make them available in this OCB mode. So if people are interested in that, I will send a link perhaps to the IPWAVE reflector, to the document that motivated that work. It's just getting started, but the goal is to basically give a generational upgrade to the PHY, the underlying PHY that OCB uses.
Okay.
The OCB mode is unchanged. All of the protocols that work on top of that, unchanged. It's the PHY layer mechanisms that would be brought forward to the modern age.
Okay.
Thank you.
Thanks, Dorothy, for that information. Yeah.
This is Jerome Harris speaking, and thanks for these updates. As I was part of the C2C, the Car-to-Car consortium that was pushing for that, I just want to give a disclaimer that indeed it has been started, but it has to also be clear that all the day one's application for car-to-car communications can be done with the current OCB system. We don't need the new generations to be able to do the deployments today. Just to be clear that it is not something that is correcting failures. It's absolutely working, but of course we have to foresee in the future, and in 2022, then we want to have better performance. That's why we have this one. Second, as was said, there was no change in the upper part, so I don't see any impact on this working group on that.
Okay, thank you.
Yeah, I completely agree. The current system supplies the functionality that's required. It can be deployed, it can be used. The goal here is to provide an evolution so that in the future, the system can grow and expand.
Sure. Here is just a politically aspect. we were discussing a lot with some car manufacturers about these announcements, and we had the issues here is that you shouldn't leave any wrong statements of weakness of the OCB. It must be very clear. We can deploy with OCB now. All the defined use cases for V2I and V2V can be done with the current DSRC technology and the ITFG5 in Europe. So it has to be clear on that. So I fully agree, but it enhances this feature as now it's also more publicly discussed on Java and other places, that it should not be understood by other SDOs that we are acknowledging a weakness on the OCB. This is not the case.
Okay, thank you. So moving on, I think, we talked about, basically, right, the ND. And now I think the question is for supporting, I think we talked about briefly about the prefixes that are hosted in the vehicle, what is the topological relation to the RSU's network, or whether, we should have a concept of an anchor, right? I think, again, the goal is not, application of, some mobile IP protocols or something, but fundamentally, like, whether we use, MPTCP or it doesn't matter. But the question is, do we need to introduce a function called a vehicular mobility anchor for this operating environments, right? I think that is a key discussion point I'd like to have. I think, I know we do protocol work here, but we have to have some, architecture for this work. From my point of view, at least, when I see the other SDOs, none of the SDOs are focusing on it from a system point of view. This focus on, like, either it's a messaging set or on the air interface, but from a system point of view, not much work is happening there. So the question is, should this working group or some other working group in IETF look at this kind of problem where, how to support, whether, how to support, how to make sure that the networks that are within the vehicle are reachable from the network, from the internet, in a continuous fashion without any impact to the sessions, right? I think, how do we manage the prefixes, and whether we should introduce the function of an anchor. If I have one argument is, if there's an anchor, we can ensure that, all the traffic enters and exits can potentially be from one central point. That way, from security point of view and all of that, we can, in an operator or either the OEM or a service provider hosting that anchor can ensure, apply some security capabilities and other things, right? Essentially, there's ingress filtering, or every packet that's going into the vehicle, you can do the gatekeeping there, right? So should we introduce a function like some anchor for this context? I think that is one discussion point, right? Other things, like essentially, like, now we haven't talked about, like, if a city or potentially, RSUs can exist every 500 to 1000 meters, right? If a city deploys it, potentially there could be hundreds of thousands of these units. How can we manage these RSU units from one central point, right? What does it take? Do we need a new protocol interface, right? Or will it be similar to CAPWAP, right? Or completely, netconf, right? I think some discussion on, how we are going to manage this, roadside units is of interest, at least from my point of view. Now, I think summary, I think we argued a lot. What does it mean in IPv6 works, right? I think what doesn't work, but I think we can at least agree that there may be optimizations in ND that may be useful for this operating environment. I think that is 1.1. Point 2, we should have some view on how, a system, how an end-to-end system can be deployed. I know we don't do end-to-end work, but if you look at some of the, mobility working groups, we did specify, like, we provide a reasonably good solution, end-to-end solution. Like, somebody can take a NEMO architecture today and deploy a complete mobility, system, right? That is being done today. Similarly, for vehicular deployments, do we need to have an end-to-end system, like, how RSUs connect to, the cloud, or how an anchor talks to all of these, or how prefixes are rolled out to the vehicle, how routing works? Maybe, one specification, maybe should we have, focus on that architecture document. That is another point. Third thing is, identity. I think, Eric talked about it. Before we talk any of the stuff, first let's establish some rules on, like, how the vehicle identifies to the network. What is the authorization model? What is the authentication infrastructure? I think, again, this from system point of view, how do you authenticate these vehicles, right? What exactly is the identity? Is it the certificate, or is it a, some ID derivative of the WIN or something, right? I think some discussion has to happen there, right? And finally, mobility support. I think, there are already other working groups, but, point is, should we leverage, should we say that these are all the potential solutions one deployment can choose, right? Some explanation on, what are the problems and what mobility solutions can be used. And finally, like I think RSU manageability. I think these, I think, in my view, are potential work items that IETF can explore. Any questions? Any final? Yeah.
Yes, this is Jerome speaking again. I would like to maybe start. I mean, okay, you have some items here. Some I agree, some I agree less. But what I mean is, we should start from the top down, starting from the top and going down. And one thing I don't see here, and we try to talk about it, and I think we should talk more about that. What are the types of application we have on top? What kind of traffic is being transmitted? It was mentioned before, how long should the session last? We have to define these kind of things because then it might have impact, might give guidances on that. If we don't do that, then we don't know what we're transmitting. When you're providing something that could work for everything, of course, maybe IPv6 can work for everything, but I think we need to be able to have some guidances from some services and some applications. There will be some presentation on IoT. Wonderful. Then we can discuss about IoT. What kind of types of thing we do that? You were mentioning this central gateway. That's fine, but this is for what? For one type of service? Is it for security? If you start centralizing something, then you automatically address it for one type of application. I would suggest to start from the upper part, to start from applications, type of traffics that we are transmitting, and then maybe go down to see where it goes. Thank you.
Fair point. Thank you. Alex.
For the applications, I tend to look at it as, well, if there is a link that is a bigger and bigger pipe, then more and more applications will appear, and that we have more and more constraints. Everybody will want to run their YouTube or Skype that keeps their session up. But you cannot run YouTube and Skype on, I don't know, on Bluetooth. You need some 802.11 AC or this NGV, if I understand correctly. So if you have NGV, then I'm sure you have YouTube, and there will certainly be a need of keep the application up. That's for the what kind of applications. For the other comment that I had actually that I came up for is this manageability. Okay. I know that at IETF it's good to have for each new protocol, each new document that you come up with, it's good to have this management information base. And I think for IPv6 over OCB, some of these musts that we put there could be configurable. And maybe a management information base would be almost mandatory. And I don't think we have it in the charter, or maybe in the future charter. Yeah. MIB, Management Information Base, Young model. Yeah.
Possible, yeah. Thank you, Alex.
So I'm confused about the discussion about applications. As soon as you turn on IPv6, you get all internet applications. You get web surfing, you get email, you get Jabber. Everything is there. SSH, sure, no problem. Streaming falls out. Gaming, it's going to fall out. All sorts of things are going to happen, and we can't exactly anticipate exactly what's going to be necessary. Okay? Now, I happen to have played with a number of these, and they all seem to just work. Because why? It's IP. The link stays up, IP is happy. There's nothing fancy to be done here, guys. Just pass the packets.
So Tony, how many IP links, when you say it stays up, how many IP links does the vehicle cross when this stays up? How many roadside units? 1, 2?
My particular application is rather special. I care about vehicle to vehicle for more than anything else.
Okay, so for vehicle to vehicle, yeah, okay, that's another thing.
So now if you want to provide mobility across address domains, you have a real serious problem, because the internet, we thought about doing that in the architecture a long time ago, and we basically vetoed that. So, that's really going to be quite challenging, and I don't think you really want to take that on.
Okay, all right. Paul?
I have some comment about vehicular network architecture. So very good. Yeah, some suggestion. So, but one missing part is beaker-to-beaker communications. You can see the highway. Many research try to accommodate the beaker-to-beaker communication to reduce delay caused by the relay by some RSU or some other anchor point. So that is we need to consider. And also one comment for the rest. So the beaker network case in highway, beaker can communicate with directly. Sometimes the intersection area, urban road network case, the congested area case, maybe RSU can orchestrate the communication. In that case, the beaker communication, sometimes beaker to beaker via the RSU, something like that. So that might be different from other mobility. Yeah, so we need to think of it. Okay.
Right. Yeah, I think the prefix exchange, right? Essentially, when the question, I think it's already addressed in this. Go ahead, Suresh.
Finish up your sentence.
No, I think that use case essentially for vehicular-to-vehicular communication that is already covered in the list of items actually. So. Yeah.
Right. So I just want to figure out what there's interest in the group to work on. Okay. So I'm going back to what Eric said. We need to have a strong handle of what we are trying to do. Okay. So all these things, like you said, are possible to do. Okay. The question is, why are we doing them? Okay. So I need serious justification for doing this work and support in the working group, for some, because I don't want a document which just you are going to read, right? And so that's the bar that the working group wants to work on something.
Right.
Okay, so you have to convince the burden of proof is on you to convince the working group that something is required. And so take an example use case, right? And say, okay, this is why it's not going to work, and this is what I'm going to do. Because any of the mobility mechanisms we define for IP, okay, any of the mechanisms we define on top of IP, right, like mobile MPTCP or multipath quick when it comes out, those things are all going to work on this, okay? So that's why I was saying MPTCP when Eric was talking, right? So they're still going to work. So even if you have a constantly changing IP address, right? We can do MPTCP with you can just as long as you have some locator, we can just keep moving on, or we can have mobile IP running, right? What more do you need on top of it? That's the question. That's what you need to say. Okay, the currently defined set of mechanisms don't work, and this is why we need a new thing. So that's the starting point for doing new work.
Okay. That's a fair point. I think I think the question is, I think few data points, right? From my own company point of view, we are, there's a lot of work happening. We have worked with many OEMs, and essentially at this point, we have been doing mobile IP or mobility protocols for a long time. But now there's some real work happening. We are working with OEMs, and I'm sure if you look at all the industry direction, right, Tesla or any of that, the amount of self-driving technology that's coming into the vehicle. You cannot deploy a self-driving vehicle and without having a connectivity to some cloud, right? There's a lot of data that there's a lot of processing that happens within the vehicle, but there's also a lot of data that comes from the cloud. So unless IETF provides some system, some specification saying that this is how you deploy it, I understand that the protocols exist. There are many protocols, but at least document them in some form. Say that these are all the options. These are the these are the issues that you're going to hit, and these are the potential solutions. This is how you deploy it. That guidance is what we need to provide, and that specifications are going to be useful. And there's a room for optimizations. We cannot say we keep saying that IPv6 works. IPv6 works. How does it work? I still don't get it. So maybe maybe it works in conjunction with other protocols, but some document has to explain how that how it all ties in. I think that's all my point is.
So let's really just to cut the discussion. So can we have the discussion on this point as part of the discussion, the problem statement survey document? So it's basically what we discussed before. We have a problem. There are a set of solutions that can be applied. So we need to document what is there, and we need to identify what is missing, if any. And if any, that will be a gap that then we can gather the interest from the working group working on that. So if we could have that kind of discussion as part of this document, I think that would be helpful for the document and for the actual potential rechartering topics. So please, if you can do so, start a thread on the mailing list, like these are the gaps, these are the problems I think should be documented, these are the solutions that can be applied, these are the whatever guidelines, best practices that is missing, gaps on the protocols, and clearly identify those. I think that will be helpful to continue the discussion.
That's all. Thank you so much.
Thank you. So, Jerome?
Okay. So good morning, I'm Jerome Harry. I'm going to briefly introduce one kind of homework that I've been doing to identify potential issues about the mapping of IP prioritizations into the IPv6 and OCB. This is also related somehow to the discussion of the IPv6 over OCB and the issues about QoS data. So of course, this assumes that we use QoS data for transmitting IP traffic over OCB. So brief introductions of basically OCB access categories. So if you take quality of service data, then you're going to have these EDCA classes. You have four of them basically. The MAC aspect for the prioritization works in two phases. I mean, two types of contention. So first one is deterministic. It's called arbitrary interface interframe spaces. So AFSN number. This is a deterministic value of number of slots per different categories. And then you have a contention windows, which is a stochastic part. So then, as you could see in the different queues, then you see the four queues. So one is called access voice, then access videos, access best effort, and access background. So of course, just to avoid any misunderstanding, this absolutely does not reflect that only voice can be transmitted on access category voice. It's more or less like a voice type of traffic quality, so to say. And you could see the values of each of the parameters. So you could see in the charts that you have 2 slots for the first access category voice, 3 slots for videos, 6 slots for best effort, and 9 slots for the background. Then the contention windows is also a bit specific. You have 4, 8, 16, and 16, depending on the guessing categories. But this is what basically 8.11/2016 OCB specifies for EDCAs for OCB. Now, of course, this doesn't say how do we match the different classes of the traffic of the ITS traffic classes. So what I introduced here was just what we did in ETSI, and there was also similarities with SAE for the BSMs. So for the access category voice, so the higher one, there was the emergency DEM. So it's like event-driven and can be transmitted with a very high urgency. The second one is DEMs, regular DEMs. Then the third one, which is best effort, is the CAMs. And the last one, background, is for any kind of other traffic. If I match it to SAE, at least we know that the access category voice is for emergency or let's say event-based BSM, and access category best effort is for regular periodic BSM. So this was actually the source of the discussions about the QoS data and the data, because this is basically the number of slots you have to wait. So if I have a specific DEM to transmit with the access category voice, I will have to wait at least 1/6 and 2 slots, and then randomly between 0 and 3 slots. What is also important is that if I don't use EDCA, if I use DCF, which is the baseline data style, then it is the equivalent is a diffs, which is also 2 slots and a SIFs. So basically, the deterministic waiting time for diff is equivalent to the access category voice. Of course, the contention window is a little bit bigger, but basically that was the source of potential interferences. One thing that is also important to understand is that so far, most of the traffic on OCB is broadcast. So the contention windows max is actually never applied. So the contention window we have is just the contention windows min. Then let's move one step up. So 802.1d, which is the MAC bridging document in IEEE, provides a set of user priorities. So we have 7 classes of user priority, and a default one, which is basically if nothing is provided. So you see here a chart taken from the standard showing that we have 7 user priorities, and the issues at the end we have also acronyms for 7 potential traffic class, or not traffic class, but 7 potential priorities from network control to background and spare bed effort. The issues in mapping is that you're going to map something that has 7 options to something that has only 4 options. And this actually, and another thing that is important is to check what's the definition of video and voice. For example, it's also related to some latency and jitter. So that was the original definition for the 1D. Later also used for 11E and 802.11 2016. So then the issue is when you map it. So if you have 7 classes, 7 user priority, and you have to map it on a specific number of queues. So again, if you look at the standard 1D, they propose a few options. So you can see on the vertical part, you have the user priorities, and the upper part is the number of queues. So what we have in 802.11 2016 is we have 4 queues. So we have a mapping from basically the first 2 user priorities are mapped to background, then the second next to best efforts. Then we have, of course, the others, CL and VOs and NC mapped again to something that would be called videos and voice and videos. So this is but this is again a potential suggestions. There is also this, if there is issues about that is not part of, it's not specific part of IETF, but this is something that was a recommendations, command of best practice, but not specifically hard-coded in stone. Now, if we move one step further, we have the IP traffic classification. So this serves Dscp, and so the differentiated service quote point with a few names, default forwarding. I'm pretty sure you're perfectly expert in that. So these are actually specifying the prioritization of IP traffic. And of course, what we hope is that if you have a specific classification on IP traffic, it would be mapped to the equivalent in the Wi-Fi layer. So the IP traffic is traffic classifications you will have in IPv4 traffic type of service, in IPv6 traffic class. Both of them take the 6 bits of the DSCP and extend it with two extra bits. So basically, if you take the DSCP 6 most significant bits, then you have, if you take the 6 most significant bits of the type of service in traffic class, you get the DSCP. And there is, again, some examples, again, taken from the IETF RFC 4594, illustrating the different service classes and the mapping to different DSCP values. So you have telephony, you have voice, and so on and so forth. And of course, let's see what happens afterwards. So the issues after that, that's worth looking at is when we map an L3 priority, which is 6 bits, to an L2 user priority, which is only 3 bits. So current best practice is to take the 3 most significant bits and simply map it. So if you have a DSCP that is 101.110, then we end up in user priority 101. This is, of course, best practice, not default. But if you do that without really taking care of it, then you are going to have confusion. For example, you have a voice type of traffic, expedited forwarding 101.110, and it ends up being UP5, which is actually not voice, which is actually video. So you have a voice mapped in video, and I leave you also have a look at the other potential confusion, which is a bit annoying in that case. The upper part is the same. At the reception, you get an L2 user priority, 3 bits, and you have to map it to a 6-bit L3 priority. And then what the best practice is to multiply by 8. You simply shift it 3 bits, and then as the example, you have DSCP. If you have the that's the opposite. I did the bad cut and paste. So if you have a UP 101, then you're going to have a DSCP 101.000. If you do that, again, you're going to have some strange mapping something that would actually be voice or telephony, then it will actually map to a specific CS8, which actually is network control. So that's something that we also have to avoid. So again, few confusion examples that you can have a look here. All of these actually are from the RFC 8325, which was recommended by Roland Bless. So thanks a lot to him to have pointed out these documents. So that's basically what does these documents. It's mapping diff serves to 82.11. So what these documents is to identify the potential confusion and suggest to adapt the mapping such that the confusion are actually relieved. And another aspect they were suggesting is to also leave it, let's say, configurable, such that it's not sealed in stone what the mapping is. Intermediate systems could configure it according to a specific controller. So this is interesting to have a look, and we might actually, part of the IPWave, also have to look at that document. So my last slide here is as input to IPWave. As we now mentioned that we have to have QoS data part of IPWave for IP over OCB, we should also refer most likely to this RFC, to the RFC 8325 for the mapping between diff serves to 82.11. What we should also do is to try to understand what kind of traffic are we going to send, because so far these are generic IP traffic. As far if there is no issues about that, that's fine. If there is specific traffic that is either doesn't enter the classical diff serves traffic that are, for example, illustrated here, here, then we might also want to add some specifications. So, for example, to avoid any confusion, if you transmit a specific type of traffic that would be critical for autonomous driving, and it ends up being mapped on the wrong queues, then that's something we might want to avoid. And last point, we also have to look at one thing that is important. If we look at the current specifications, we have, if you have a user priority 0, which is the default one, it is mapped to best effort and not background. So we have to double check that, because as we explicitly mentioned to the RFC, to the ID we discussed before, that we should map it to background, then we have a confusion with the default mapping 0. So one potential option would be to have to mention that we should have a default mapping to background, and that would mean that we simply change the definition of the default mapping from best effort to background, such that we share the same language. But nevertheless, this is just up to discussion. So point here, let's see. I mean, I still need to dig into more about this aspect to see if there is something that is worth bringing into this group. But at least that goes also for respect to my previous comments. We need to define the type of traffic we transmit, and based on the traffic we transmit, we should see if the priorities are correctly mapped into OCB. Thank you.
So Tony Lee again. I apologize for repeating comments that I made on the mailing list, but I have to bring it up again because I don't see how this works operationally. We have no security over DSCP. Anyone can set anything in their DSCP value today. And unless you happen to traverse a network that actually implements QoS, and not all do, and unless that network actually remaps DSCP, then the DSCP value you get is whatever the user decided. Now, there are a couple million aspiring Linux hackers out there, and at the drop of a hat, they will change their DSCP value so that they can transmit their peer-to-peer porn at voice or video priority, whatever gives them the best throughput. How are you going to prevent that?
Okay, I didn't understand the end, because could you speak a bit louder?
I'm sorry, I'll get even closer to the mic. So the basic question is, how do you prevent DSCP from being forged?
Oh, that's a good question. I don't think it's an issue. It's something that we have to address in that working group. I didn't look into that. Maybe I have to.
Well,
maybe I have to. I agree.
We, as a broader internet, do not have a way of preventing that today.
Mhm.
And as a result, the DSCP values are not guaranteed unless your network has overwritten them.
Mhm.
And because we are an end user network here, there seems to be no mechanism for doing that. So I don't see how you can do anything except cause yourself to be hacked by doing this.
Okay. Well, I mean, we can start. We can work in three steps. The first step would say, okay, assuming we don't have the DSCP, then we still have a default mapping, and the default mapping, as it is mentioned now, is still access category best effort. It's not even the DSCP that is mentioning it. It's actually 11 is 1D. You can see that if you have only one queue, then it should be best effort, which is not what we should do. If we basically have 4 queues, then we have the background and the default, which is I think the one that is I don't show it here, is not mapped to background. So this is something that if we leave it as such, if we take a default user priority would be mapped to best effort and not to background, which is opposite to what we discussed before. That's the first step. The second step is we can already look at where, I mean, if there is a way to consider DSCP first as not being a source of hacking, but just to see if it can work. And then the third step would see, okay, if it's a source of being hacked, then maybe it's not useful. We need to secure it. That's something beyond my expertise. But there is a standard. There is this RFC there. So I think it's important that this group at least have a position with respect to these standards. Can we apply it as such? Do we have to modify it?
I think that applying it without thinking about how to secure it first is a major mistake.
So, Jerome, I agree with you with that default 0 value. I did not know it. I think that could be a problem and should be fixed quickly.
Mm-hmm.
Now, with respect to DSCP not being secure, if you look at it like this, yes, anybody on the internet could read the DSCP in a traffic class and then replace it with something else, like a man-in-the-middle attack, and send some bad traffic to the car instead of the legitimate some. But I think this could be secured with IPsec because DSCP is part of the IPv6 header. And IPv6 header is covered by ESP and AH headers of... no? Okay, so if not, then let's secure it.
Yeah, but I mean, just as a disclaimer, I do not advocate to use DSCP because the only thing that we have been advocating for a couple of weeks from now is that we have QoS data at OCB because we just have to. The underlying discussion was if you have EDCA, so QoS data, it would be nice to be able to map it to DSCP. And that was the reason why I have this. So it's not that I'm advocating it. I'm just mentioning that there is an RFC about it, suggested by Roland Bless. And it would be nice to look within this working group whether this applies to Wave or to IPWave, or whether it does not apply to IPWaves and needs to be changed. That's all what I was trying to say here.
So thank you for the suggestion of IPsec. That doesn't change the origination of the packet at all. Prevent from anyone from
You want to answer that?
If there are some certificates that are used here, then there is some certificate authority, and yes, it could be garbage, but it is maybe certified garbage, and we could identify who certified it, and it's traceable if certificates are there.
Sorry, there's no certification on the source address in the internet, and we get garbage source addresses all the time.
Okay, Suresh Krishnan. So if I understand you correctly, Okay, so because like it's not clear from the presentation. So do you want to take the traffic types and map them into DSCPs, or take the DSCPs and map them into like lower level code points? Okay, because 8325 does the latter. It takes the DSCPs and maps them onto like, whatever the, the ACVO and those kind of things. So, I have a hard time seeing like what you're proposing, to be very frank, right? So are you proposing a BIS for this, like based on if there's a change needed, or are you mapping a parallel document to this, which talks about what's on the leftmost column? So that is my first question, okay? So second thing is this just passed through, I would say 2 months ago, right? And I have a hard time seeing something has changed radically in the last 2 months. Okay, so quite again, like just like I told Sri, like we need a bit of justification on like why we want to do it, and actually also what we want to do. So, so explain if you're going to change the mapping, or you're just going to change the labeling of the left column. That's the first thing I want to know.
Okay, so first of all, it was just this was just meant to basically discuss. So I'm not proposing anything yet, but the direction I would at least try to dig into a bit more is first to be sure that I have a traffic class, whether I use DSCP or not is another question. So I will have a direct mapping, it will be default mapping, and I want to be sure that this default mapping goes to background, not best effort. So this is something we have to double check. Second, we have to check, and this is related to one of my remarks. We have to define what kind of traffic we're going to transmit within IPWave, and how that could match such that whatever is mapped. So if I just use default mapping, then it will be automatically background. If I want to add a bit more, that was also related to this. If, for example, I have an IPv6 traffic that has the same level of priority as a BSM, either because it is a BSM or because it is something that has the same meaning of priority, how can I then map it to the right queue? That's all.
Right. So the DSCP to 802.11 mapping is done, right? So if you solve the first problem, like how would IPWave traffic map it to DSCP, the second problem is automatically solved. If you believe the mappings in 8325 are correct, right? Yeah. So because like what the 8325 DSCPs map into on the L2, so the only job we have is like then take the IPWave traffic and map it onto the right DSCPs, right? So that's what I'm saying. So there's like two different questions. So you can go either way, but I just want to like have clarity on which way you're proposing to go. So from what I understand now, like you want to take the IPWave traffic types and map them onto some DSCPs. What DSCPs you use? Is that what you want to explore?
Yes.
Okay.
Okay. Thank you.
Thank you.
So Paul. So we are a bit ahead delayed, so if you can shorten your presentation, I would appreciate it.
Okay, so let me introduce some three the topics for possible work item. So I will briefly explain. So I would like to suggest the three work items. The first one is the vehicular neighbor discovery, especially the prefix discovery for the routing, and second one is left feed service discovery. And second one is Dns Naming Service in terms of name auto-compilation of in-vehicle devices, and also device and service discovery and DNS name resolution. The third one is seamless IP networking in terms of the change of MAC address because of a pseudonym to protect the privacy of a MAC address. So this is the vehicular network architecture. So you can see vehicles can communicate with each other directly or it can communicate with the infrastructure. Also, we have a traffic control center. It is central road maintaining the position and the trajectory of vehicles. So maybe this traffic control center may be the mobility anchor, the three I mentioned before. So I assume internal in vehicle or RSU, it has internal network, which means multiple subnet may be constructed like this. So vehicle one, RSU one, it has some host and the servers. So the question is how to communicate between some host and the server quickly. Second one, also similarly, the two vehicle can communicate with each other. The scenario is within vehicle, it accommodate multiple subnets. The question is some host and another host in another vehicle, such as the adaptive cruise control or pro-tuning service case, they should communicate with each other. So in order to that, we need to support the prefix exchange. I would say prefix discovery, which means rapidly find the other vehicle internal network prefix. The second one is the service discovery. So internally, they accommodate some services. I mentioned the adaptive controller or pro-tuning service, some social network services. So the question is how to advertise their services quickly. So I suggest the two options for them: vehicular prefix information and service information prefix. The second topic is DNS naming service. So the first one is in vehicle devices, maybe some engine or some other the wheel or the user's mobile devices, maybe the in-vehicle devices. So the question is how to accommodate the auto configuration of their name without intervention of users. The second one is device discovery. So in-vehicle devices can discover other devices by getting DNS database DB, such as a JSON file. So it can achieved by from the DNS server. So and service discovery similarly, we can discover service. Last one is the name resolution. So this figure shows the step DNS auto configuration. So IoT device, we can say the in-vehicle device can get a route advertisement having the DNS search list and generate its name and double check the uniqueness using DAD, because DNS name can generate its global IP address. And then router can collect the DNS name and address using node information query. And then router has some authentication to deliver its IoT device DNS name to DNS server using DNS update. After that, user device can figure out the in-vehicle device using the contacting with the DNS server. The last one is seamless IP networking. The handling of a MAC address change because of the pseudonym to protect the privacy of a MAC address. The problem is MAC address change means IP address change. So in that case, ongoing TCP or UDP session can be broken. So we need to handle. So one possible solution is we can using some mobile IP binding update. So also this issue case, some vehicle moving to some area and other vehicle using the same IP address. The address is conflict, right? In that case, we also need to resolve this IP address. Secondly, vehicle can approaches the RSU coverage. So we assuming another RSU providing different the prefix IP address will be changed. So in that case, also we need to handle the change of IP address. So next step is we can consider this topic for our work item for rechartering. the problem statement case, I also describe those problems. So we need to design a detailed vehicle network architecture, consider V2V, V2I together. Thank you for your attention. Any questions or comments?
Okay, thank you, Paul.
Okay.
Alex?
Hello, my name is Alexandru Petrescu, and I have a very brief presentation of my and my group current concerns of about some trials we do with IP for V2V and V2I communications. I separated this in two parts. First, I will talk about V2V. I have 2 slides. And second, about V2I. In our trial, we use here on the left side, we use 3 vehicles. You see them, they are following each other. And they are a little bit particular compared to other vehicles that we've seen in other trials, is that they, well, first they are small. Okay, so you have self-driving cars that are small. This is a little bit new. And also they feature, each one of the vehicles features actually not one interface on the top of the roof, but 3 interfaces. One on the top, one in the front bumper, and one in the rear bumper. Okay, so the vehicle communicates from one vehicle to another by using the front bumper to the rear bumper using OCB. And we put IP on it. So that's a V2V technology that uses IP over OCB. An alternative that we also consider is on the right side of the of this picture, where we also have 3 vehicles. But, yeah, it's 16.9 instead of 4.3. So, but basically, you have on the top of on the roof of the car, you have 4G today. In the future, 5G NR that talks to an anchoring point, and that uses DHCP prefix delegation. So you realize V2V communication, but through a first hop router that is fixed in the infrastructure. That router is not called a roadside unit. It's called something else, I forgot, PGW or something. Okay, so those are the 2 V2V topologies that we must make work, and we will make work soon. And these are the requirements that we have. Some of them are easy to satisfy, others are very difficult, and I'm not sure. But first is the dynamic distributed decision of which 5.9 gigahertz to use between cars, such that to generate the minimum interference. Second is establish paths linking all IP nodes in the cars. And third is to distribute somehow the address of a DNS resolver, such that when computers talk to each other, they don't use IP addresses, but the application writer can use the name of some other computer, not its IP address. IPv6 addresses are very long. Potential solutions that we have experimented with are the Babel routing protocol is trialed okay on 802.11 OCB for V2V. We also experimented with prefix exchanges in IPv6 router advertisements, trialed okay on 802.11 OCB, and DHCP-v6 prefix delegation, trialed okay on 4G deployment. So that's about V2V, and this is our requirements right now that we look at, and maybe some of them are compatible with what other people would like to do at IETF, or we will try to understand this. Now, going to V2I, we also have a V2I context. The V2I is something like this. You have one car that wants to talk to maybe a home agent or a IoT platform in the internet, and that sends its own data to like its current speed, or many IoT devices are in the car, so it sends all these IoT data to this central server, if you want, that is situated in the internet. And there are a couple of roadside units deployed along the road, and each one of them sends a router advertisement, and then we want to perform a handover between one roadside unit to another IP roadside unit. And for this, we need to do movement detection, but movement detection, as specified currently, is based on measuring the signal strength. And the signal strength is measured on the beacons of Wi-Fi today, when we use Wi-Fi. If we do it with OCB, we don't have beacons. So how to implement this movement detection when we have no beacons? So the requirements are here. The problem is that for mobile IP to work in V2I mode, a movement detection procedure is needed. Current movement detection procedures on mobile routers measure and compare signal strength of different beacons. But 802.11 OCB has no beacons. So the requirements is that a movement detection procedure that measures the signal strength of an IP message, some IP message that could be used as a beacon. And this message that is IP should contain enough IP and layer 2 information to assist the mobile router to decide it must change the subnet and then decide to send the binding update to arrive at our beloved mobile IP. Okay, and it is not sufficient to just put the MAC address and the IP of the IP RSU and the prefix of the link. This is not sufficient. You need much more to realize it. So, yeah, the requirement here is to identify which is this IP, a regular IP message, maybe a router, maybe an enhanced router advertisement, or some other IP message that could be used as a beacon. So that's the end of the requirement for movement detection in OCB mode, and this could probably be fit into the neighbor discovery discussion, if neighbor discovery means router advertisement or neighbor advertisement. And yeah, this is the things that we work on right now and for which we'd like to have solutions soon. Yep.
Eric, not Mike. Go back to the V2V slide. Or was it B2B requirement? Yeah. So my question was about, okay, so you have DNS and IP prefixes, that's great. How does the applications actually rendezvous? How does the application in car A know what domain name to look up to talk to car B? It's never met it before.
Yeah, maybe we'll hard code it first, but it's a good question.
For all the cars on the planet?
No, no, absolutely not.
No, but you have to start from the top. It's not useful to build these mechanisms because they might not be needed.
Do you have an idea about?
You might not be using the DNS, so why would you want to find a resolver?
Okay, but then we need some name to address to name and name to address resolution.
No, you need application rendezvous, and those are merely. Today we have a bunch of steps, right? But it's not clear that that makes any sense when I have two cars that happen to be next to each other for 3 seconds, that you would want to use the same set of steps. You have two applications that should talk to each other. They somehow know they should talk.
Okay, just hold on one second. For our deployment, it's 3 cars, okay? And they stay together for maybe 1 hour. It's platooning.
This is the Internet Engineering Task Force, not the Lab Engineering Task Force.
It's not lab. Okay, think about taxis, car sharing. This is not lab. It's not laboratory.
Platooning or what?
Yeah. I mean, it's
but even the platoon, they form as they come out on the highway, right? That's the division.
There are many kinds of platoons. Okay, this is why there is convoys, platoons, and there is rebalancing of the cars from one station to another. There are many. It's not only highway. Highway is just one thing.
But you're saying that you would pre-configure them in the factory, or someone would go SSH into the cars and tell them who they're supposed to talk to?
Yeah. Okay. I agree with you. I agree. Okay.
That doesn't make sense.
The application need the rendezvous point, the high-level rendezvous point. How would you propose to make that, if not with DNS?
I don't know. It has a camera. It reads the license plate of the car in front of it. and then it uses that to actually figure out which link local address to go talk to by using a multicast to find something. And then it needs to have something that can secure that communication, like the license plate having a QR code with the public key, the key fingerprint or something, right? But it has to bootstrap from something, not saying it's the DNS. I have nothing against the DNS, but it seems like the wrong, recreating the same stack we have created for fixed communication for this entirely local and extremely ephemeral communication between two neighboring cars is like you're starting with the wrong premise.
Yeah.
Right? And I don't know what the key thing to me is how do we secure this thing?
Yeah.
Which is why a QR code with a key fingerprint on the license plate might be a reasonable thing. Because now I can actually see that if I send something over radio, I actually know that it's that thing that has that QR code printed on its license plate.
Yes.
Whether that's a good solution, what the privacy considerations are, there's lots of questions still. But at least I have a way of bootstrapping this in the physical world as opposed to thinking about the current internet approach to doing it.
Yes, I agree. So it's true that going with saying that it's a DNS problem is probably the second or the third step. And first, maybe we need to think about some bootstrapping of communication between this, and this comes down to writing some imagining a problem statement that first talks about bootstrapping. Yeah. Maybe.
This is Jerome Harry. Related to the second part, in different SDOs, usually what happens is you have an application that sends a service announcement. It's announcing that he's a service provider, and the other one is a service consumer. And that basically, if you look at 1609, I still have to look with details on how it works. They don't have DSRC beacons either, but still they can manage to keep a service, 1609 service, IPv6, when moving from one RSU to the other one, because there was service announcements provided by the different RSUs that can be tracked.
Yeah.
So either we can use the same strategy, but the point is we have to be able to define the service, the concept of service, because if I want to consume a service like an IoT, I need to know that I'm a consumer or provider of a specific service, and therefore I had to announce it. And that could be used to track, to link it. And the second point about what was mentioned before about the bootstrapping, of course we have to, but again, I'm still a bit skeptical about why using pure IP to do these ephemeric communications, whether there's other standards doing exactly that, secured, no problem. So maybe this is maybe not what we had to be done in IPWave, but on the other hand, the second part, when you want to connect to services, this is where we should go. But that's just my personal comment. Thank you.
Yeah. So I have answers. But, yeah. So service announcements at other standards development organizations, yes. Also, IETF has service announcements, service description protocol, service announcements. There is also, we could reuse this SDP from IETF. Why not? And why using IP and not the link layer protocols defined at other SDOs? In one of the slides, I showed this V2I. It is a very strong requirement to be able to connect from the car to a server in the infrastructure. And basically, you end up sending the same data, the same IoT data, both to the server and to some nearby car. Okay, they want it very often to send it twice. And this is obviously inefficient. And you just want to be connected to the internet. Whether that internet is the car next to you or the cloud, or you see, this is why only if you use IP, you are able to homogenize and. Yep.
Hi, Tony Lee again. So we seem to be again talking about things that are not really OCB specific.
Yes.
There are lots of things that have been done in this space. I'll point to link local addressing, takes care of a lot of the problem here. And then zeroconf takes care of many of the other issues that have just been raised. Let's not reinvent the wheel, please.
Yes, so many of these things are not OCB specific, but they are all IP specific. And I think we should use IP.
Zeroconf is an IETF working group, not new.
Yes, zero configuration was an IETF working group. Yep. Thank you.
Just as follow-up for you, the first comments on the on using IP on B2B communications. It's important to also know that there is currently strong specifications both in SAE and in IETF in the fact that you will be exchanging sensor data with L2 protocols only. So they will be exchanged no matter what. And then the question would be, okay, if you want to transmit it somewhere else, then you have an additional protocol. But using IP will not replace it. Will not say, oh, I can use, by using IPv6, I can avoid transmitting twice. This is an efficiency issues, but the L2 protocol will transmit sensor data to other vehicles without IP. That's already done and will be specified very soon. You have an ETSI, a specification called cooperative perception message, and SAE is standardizing exactly the same types of messages is L2 only. And therefore, if you want to transmit it to IoT to the internet, which I have nothing against, I think it's a good point. In any case, you will not be able to block that. This is a standard service that will be provided for platooning and car-to-car communications.
Well, but you will not want to send both of them, right?
Sure, but this is different services. One is an IoT type service, which is someone in the cloud wants to do something with the data, and the other one is autonomous driving.
No. Even the cloud is cloud for autonomous driving.
Sure, but nevertheless, you might want to transmit it to an IoT MEC if you want, to an IoT edge. To an IoT gateway if you want, or even you might want to transmit to an LDM that is on the edge. No matter, but still, even if this is done, it will be done in L2. That's very important to understand that.
No. It's not on L2 when you are on 4G or 5G. It's on IP. When you're on 4G or 5G, it must be IP. It cannot be anything else.
But then it will be twice. Because
so you'll send it twice on OCB, and is it acceptable?
You will do it anyway. There is no way they can avoid that.
Yeah. Okay.
Eric Nordmark, echoing what Tony said about, yeah, we have a bunch of mechanisms that already exist for this stuff. But I think that there's one thing that we haven't done well before, whether that belongs here or somewhere else, which is figuring out, okay, I have some form of identity. It might be a linked local address for local communication. But what is the relationship between that identity and how you secure the communication? Okay? And that might, as I said, not belong here, but I think it's one of the key missing pieces.
Yes. So yeah, the identity and security in this highly dynamic environment, yet well-structured environment, because the cars are structured, is a sensitive topic, and we could address the problem also from the identity and security, from the security and identity standpoint, and yeah, so that's all I had. These are the kinds of things that we would like to work on, and we hope to produce some prototypes and demonstrators with this, and yeah, that's my.
Thank you. So, well, the remaining minutes were supposed to be for additional open mic discussion on the rechartering. I don't know if anybody else have any comment. From my point of view, what I think we should do next is, as we have been discussing, to basically, for each of the problems people think work is required to actually present, describe the problem, analyze what are the solutions out there that could be applied to that, document this, as part of the other document that we have, this problem statement and survey document, and identify potential gaps that you believe are not sufficiently covered or that require additional optimizations from the staff that is already there. If we have that discussion, I think that could be used for then decide whether the working group wants to do additional things under the required commitment from people to work on that. And then based on that, we can see whether there is something that needs to be done or not. That's my take on this. I guess, Suresh, you agree on this, right? This approach? Suresh?
Yeah, makes sense.
Okay, so any additional comment on potential rechartering topics?
Yeah, well, so there was this that I said that we exchanged a few with 2 or 3 participants on the email list about sending these what they call L2 messages like CAM in Europe or BSM in America, sending them over IP. That was a topic that could be also explored, sending CAM over IP instead of sending CAM over geo-networking, for example. That was an additional topic.
Okay.
One more item I heard that I'd like to endorse is actually the concept of doing a MIB for the radio. That seems like worthy work here.
Von der Deutsche Telekom, I just wanted to summarize what I saw in this discussion on the rechartering. This is not all to do with OCB and 11P, but I think this is also on infrastructure modes and on communication with the network. And so in coming back to the first announcement on the liaison statement, so we are also working on perhaps cellular or 4G and 5G aspects of vehicular communication. So for rechartering, I would try to include this in the new charter, that we are not only based on direct communication, especially because the DGP also has this direct link within their specification. And also I think we need higher security, also what it said, on reliability, and this multi-RAT or heterogeneous communications for vehicular applications require for including also the network. So as speaking for operator networks, but I think we should include this in the charter.
This is Jerome Harry speaking. During when we wrote the first draft on OCB, there's one thing we postponed. We put it out of it. It's security. If we use OCB, we don't have any security, L2 security. So the open question is IP providing a bulletproof security for what we do already? If yes, wonderful. If not, at least we should provide guidelines for that. Because if you use IEEE 1609 or IETF, they have a very strong, I mean, maybe not bulletproof, it's not that kind of things, of course, but there is a strong security mechanisms, including anonymizations and change of pseudonyms. And the question would be, do we have to do that in that group? Do we have to change our IP prefix? How often do we have to do that? Should we synchronize to 1609.3 when we do that? And how about security? Because otherwise, there was from my perspective, there was an issue in that.
Okay, about our survey and problem statement document. So during this working group meeting, we discussed what is the next step. So current document survey many topics. So we need to focus on some of them, right? So I would like to suggest some additional section to focus on our working group work, right? So during this meeting, or also after Melanie's discussion, we can speak up and what work we should be done, this working group. And then I will merge and then I add additional section for our working group. Thank you.
On IT security, no, IP is not bringing security to OCB. IP lacks security. That I think should be pretty well known that we've got giant security problems, yes, by design. So don't go looking to the IETF for help. We don't have any. As far as the security mechanisms that are already built in, my understanding of the situation is that it amounts to rotating MAC addresses, and that is typically going to break everything in IP. The MAC address is associated strongly with the IP address. The IP address is strongly associated with your sessions, and so as soon as you change the MAC address, you're going to basically break the TCP connections. So you can't change the MAC address when anything is active. If you only change the MAC address when the vehicle is, say, powered on initially, that means you can't have TCP connections while the thing is off. That also means that you're going to break anything when you key on, and that's a problem. So from my perspective and my implementations, you can't actually change it, and that actually doesn't work at all.
Suresh Krishnan. So just answering Tony, like it doesn't break really. So we had an experiment like that we did with MAC randomization at the IETF, and there's like a summary report I think Christian Hutema wrote. Like there's some stuff that breaks, but there's most of the stuff works. Okay, so I can point you to that after the meeting. Okay, so like other than that, like I'm fine like exploring all these things, but in a reasonable time, I would like to see a shorter list of items. Like there's like a lot of things we can do. First thing is to figure out whether we should do them here. And the second thing is like, who's interested in doing it. And then we can continue this process. But I really want the other document done. Okay, so before we do a real recharter.
Yeah, this is Jerome Harris speaking again. One thing that might be also related to what was mentioned before is the relationship of the IP wave with other standards. Because if, for example, you have IPv6, I mean within IP wave that is operating on the vehicle with the 1609 operating, then you will have to change your MAC address because the DSRC will change its MAC address. So then you will have to do that not to break any security and anonymization from the 1609 and the same for Etsy. If the card does not have 1609 on there, then maybe I'm speaking too quickly on that, but maybe then we can do what we want. But we probably have to clarify how we interact with the different standards to see if we have a strong link or a strong ties with them, because then we basically have to do what they do, and then we have to adapt.
Hi, Sandra Cespedes. I just have a question regarding the document of the problem statement, because you said we need to focus on specific problems and then maybe provide some of the survey solutions that we have there. But I don't see a direct relation with the problems that they put together today for the rechartering. So are we supposed to include those? Because some of them are mentioned in the document, like the link models and IP mobility, but some others are not from those that we saw today. So you said we need to find the gaps and mention them, but we are lefting out some of the problems that they mentioned today.
So my point is that we need, of course, it should be the consensus of the working group. What are the problems that are worth being explored? So we need to have that. I mean, and this requires consensus. So we need to discussion in the mailing list. Then out of that, or from that set of problems, we survey solutions that apply and maybe document how those solutions could be used. And as part of that, we identify potential gaps. And that's the problem, kind of the problem statement part of the document, like, okay, this is not yet done or addressed, or there is some optimization that could be applied, this kind of thing. But I mean, we need to agree on the problems that we want to document in the document. And that applies to the existing solutions. There may be that is, I mean, we need reviews from the working group to see whether the working group agrees on what is in the document is fine. Something needs to be removed, something needs to be added. So we need that anyway. And the proposal will be that for the rechartering discussion, to ensure that whatever topics are meant to be potentially addressed, those should be in the document, because it doesn't make sense to have a potential rechartering topic, which is not in the problem statement. So that for sure.
Okay, so we should collect those things and then rewrite the document according to.
Yeah, but for that we need discussion on the main list because so far it has been almost nothing.
Okay, thank you.
Okay, so if well, I think we are just in time. So thanks all for coming. The meeting is adjourned.
Thank you for your coordination. So after the meeting, I tried to initiate the discussion. So the one thing missing is what kind of work should be done our working group. So that is the current our survey problem statement is just to analyze existing research and use cases. So I would like to make an additional section to address what kind of work should we focus on.
I think this is my personal opinion. It will be discussed in this. I will as a document like we need to describe problems that the working group thinks should be addressed. And then describe solutions that can apply to those problems and recommend a bit how those solutions could be applied. And then in that analysis or that guidance, identify open issues. I don't know. Just to put an example, efficient operation of neighbor discovery in regular. This is like a problem. Right. And you can group problems in different categories for the interoperability of the problem. But this is one problem. So you can say, okay, this neighbor discovery, I know that there are some extensions discussed in this area for multicast over Wi-Fi, over neighbor discovery. So those are things that are being discussed. Is this enough for IP over OCB or not? If not, what are the gaps? This comes to 3 points, an Alex point, okay, this is required, I don't know, whatever. So this problem, solution, gaps. But the same thing for different problems. That would be the way I do it. Then you have to kind of the problem statement and the survey well